Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 16. This is Section 15.2, problem number 16. We want to take the integral of x over the square root of x squared plus 5 dx. And again, the reason why we can't just go ahead and solve the integral is I have a variable in the denominator, and the only way really to get it out is to use the substitution method, rewrite it as a different integral. So my first step is going to be choose u. Well, I actually have two choices. Stuff in the parentheses, I don't have parentheses really, so I'm not going to go with that. Stuff in the denominator, I do have a denominator, or stuff under the root, I do have a root. So the question is, will my u include the square root symbol or just what's under it? Again, the last option being power of e. I have no e, I can't use that one. So it's either u is x squared plus 5 or u is x squared plus 5 all under a square root. Now to choose which one is my best choice, only one will work. The other is going to take me to a dead end. Keep in mind the next step is going to be du. So if I include the square root, which is essentially a 1/2 power, and it would involve some parentheses actually. To find the du, I'm going to need the chain rule. I would bring the 1/2 down in front of the parentheses, leave the parentheses, reduce the half by 1, times the derivative of what's in the parentheses. Very unlikely that I'd be able to just turn that into an x. So what I'm going to do is choose only what's under the root. U is x squared plus 5. Now du would just be 2x dx, which is much more likely to match up with this than that whole chain rule thing I was talking about. So du is, the x squared gives me a 2x. The exponent of 2 comes down times the number in front, which isn't written but understood to be 1. 2 times 1 is 2. X to 1 less power. The second power drops to a first power. The 5 on the end has no x with it, no variable, so its derivative is 0. I have 2x plus 0, which is really just 2x. And at the end, I put a dx for derivative with respect to x. Now I want to rewrite this. Now, notice the way it's written, the dx is on the end. I could have just as easily written it up with the x. Putting it on the end or putting it in the numerator is the same. So I could have had x dx over the square root of x squared plus 5. This is a little nicer match for what I'm going to have to replace it with. I can see I'm off by the 2, but that's an easy adjustment. So when I rewrite this, I'm going to have the integral of, the denominator is an easier match, so that square root of x squared plus 5 is square root of u. Now the top, I have to replace x dx. I almost have an x dx. I have to get rid of the 2. This has come up a few times, easy enough. Cancel 2 by multiplying both sides of my equation times a half. So a half times du is equal to a half times 2x dx. On the left, a half times du is 1/2 du. And on the right, 1/2 times 2x dx, the 2 and the half cancel, leaving me with x dx. So now as I finish replacing my x's with u's, I have to swap out an x dx in terms of u. I have an exact value for x dx. It's equal to 1/2 du. And as I've done in the past, that adjustment of 1/2, it has no variable. So if I want, I could leave it inside the integral. But I also have the right to pull it in front of the integral, which I'd much prefer to do. So I'm going to have 1/2 the integral of du over, instead of square root of u, let me write as u to the 1/2, and then let me take that one step further, leave the 1/2 in front, integral of u to the minus 1/2 du. See, I can leave it in the denominator with a positive exponent, or bring it up into the numerator with a negative exponent. I have to write it in the numerator in order to apply my integration techniques of, I'm going to go 1 over n plus 1 u to the n plus 1. So the 1/2 in front can stay in front, 1/2, and then it's going to be times 1 over the exponent of minus a half plus 1 u to the previous exponent of minus a half plus 1 plus a constant. So I have a few halves. One of the halves is from my adjustment of my du, and the other half is from actually doing the integral where my exponent was minus a half. So the half in front, just leave it in front, times 1 over negative a half plus 1 is positive a half, right? Think of the 1 as, again, a 1 or 2 over 2, 2 halves. That's still a 1, but now I have my common denominator of 2. Minus 1 plus 2 is positive 1. U to the minus a half plus 1 is positive a half. Same process. Plus a constant on the end. Now, simplify that a little bit further. This 1/2 out in front, I'll leave it in front for one more step. I have 1 over half. So again, when I have a fraction in the denominator, what I want to do is invert it or flip it. Basically, it'll flip to 2 over 1 times the numerator. 2 over 1 times 1 is 2 over 1. Or just plain old 2. I'll write 2 over 1. You can kind of see what's going to happen in front. The 1 over 2 and 2 over 1 can cancel. U to the 1/2 plus a constant. So now, as I was saying, 1 over 2 times 2 over 1, I can just cancel that all. So my answer will be u to the 1/2 plus a constant. Let me put the u back in terms of x. So I'll have x squared plus 5 to the 1/2 plus a constant. Or if you prefer, I would have that 1/2 power, you can write it as square root of x squared plus 5 and then plus a constant. Two different forms for the same answer.